Okie dokie. So yesterday, what were some things we discussed yesterday?
Parts of the periodic table.
Parts of the periodic table, and that was pretty much the bulk of it.
Yeah.
Okay, and we learned the basics. We learned about compounds, molecules, different types of formulas. We also learned about the 7 diatomic elements, which are known as close.
Noble gases. No, wait.
Brinkelhoff. Yes. Don't forget Brinkelhoff. You will need to know Brinkelhoff. So we talked about that, and then we started getting into the notion of ions. And what ions are, they're essentially atoms that either gain or lose electrons that will cause either a negative or positive charge. When you lose electrons, you become positive. When you gain electrons, probably guessed it, you become negative. Let me know why that's the case. What's that?
Because they're not neutral.
Aha! There's that word. Neutral, yeah, because originally we start with neutral atoms. But if we gain or lose electrons, that means we have an imbalance in protons and electrons. And if we lose electrons, that means we have more protons. And protons have what charge? Positive. So therefore, we'll have an overall more positive charge on the ion. So that's the gist of what an ion is and how it gets its charge. Now, there are 2 types, cation and anion. And here's how I always kind of show people how to remember which is which. So if you write out cation right here, okay? If you notice in the word cation right here, what does that look like? A plus sign. T, yes. Cation has the T kind of looks like a plus sign, I guess, depending on how you write it. But if you write it like this, it looks like a plus sign. Or cats are awesome, they're a plus. There we go.
That's how I read it.
Hey, whatever way works for you, that's perfect. I do love my cat too. Anions are going to be the exact opposite, obviously. So they're going to be negative. Okay? And if you look at the word anion, it's got this. A-N. Okay? Whenever you see the beginning, words with the beginning of like A-N, usually it's not good. Like, you know what an antagonist is? Someone who's pretty much the opposite of the person we like. Okay? You would say that they're more negative. All right? Antonym. It's going to be the opposite of a word, right? So, anions are typically going to be the negative charge ion here. So we're going to be looking at a couple different samples here, just talking about ions. One thing I did want to point out to you, I talked to you about valence electrons, right? And how group 1, group 2, everything like that. Okay. I'm going to keep that in mind. And we'll talk to you about some of that here. There we go. All right. So up here at the sample exercise here, we are to give the chemical symbol, including the superscript, indicating the mass number. Okay, this is nothing new. We did this before. For the ion, that is where it's different. Okay, we're going to be writing chemical symbols, but this time we're doing the ions. We have an ion with 22 protons, 26 neutrons, and 19 electrons. Okay. First thing, trying to get my seat to go down. All right, so first thing is we determine what element it is. Okay? And what element is this particular ion in question? How do we figure that out? Well, look at how many protons. Okay? Excuse me. Because protons gives us what? No? I think I phrased the question kind of poorly. Protons is our atomic number. Okay? That's got I phrased it not the best. I'll admit that. So anyway, 22 protons is going to indicate the atomic number of the element. And that element is going to be titanium. Okay? So, how do we determine the mass number again? How do we determine the mass number? Yanni McGee. You promised you weren't going to do that.
Like from here on a table, or is there an equation?
For the mass number.
Is it the 47.86?
That's what's on the periodic table, but for this particular ion,
Oh. Is it the atomic number plus the protons?
yes. Well, atomic number is protons. Atomic number plus rhymes with neutron. Neutrons, yes. The atomic number plus neutrons. That gives you the mass number. So, as you see here, I'm going to try to accentuate this a little bit. Where to write this, you put the mass number, so 26 plus 22 gives you 48. Okay? So again, the mass number goes in the upper left of the chemical symbol. Now, if we look at the number of electrons it says it has 19 electrons and 22 protons. So, how do we determine the overall charge on this ion? What do you think? You subtract them. Find the difference. And so 22 protons minus 19 electrons gives you 3. And since there are more protons, you get plus. Exactly. So you put the charge of the ion in the upper right. Okay? And yet we're going to do some to where we can see it easier on here. I'm just kind of walking through the sample exercises here. Now, I do not care if you write plus 3 or 3 plus. I do not care. So don't get caught up on that. Next one says the ion of sulfur that has 16 neutrons and 18 electrons. Well, we know it's sulfur, so we just have to find it on the periodic table because it doesn't give us the number of protons. And we can't go off the number of electrons because we're talking ions, because that would give us the wrong element. It's always got to be protons. So we hopefully will soon know, if you don't know already, that sulfur has a symbol of capital S. Okay? And once you find it on the periodic table, you see that it has 16 protons. Okay? So it said it had 16 neutrons, 16 protons, so it has a mass number of 32. That goes in the upper left. But it said it had 18 electrons. Okay? So if it had 16 protons and 18 electrons, what should the overall charge be? Charge. Why? Well, okay, we got to negative, which is the correct. But why did we get to negative? How many electrons did it have? How many protons did it have? So what's the difference? And how many are in greater amount? Electrons, and electrons are negative. Okay. Kind of like this little pointer thing. Okay. Let's look. I told you it's exciting today. All right. Practice exercise time. How many protons, neutrons, and electrons does the Se79 or selenium-79 ion possess? Okie dokie. So we're going a little different route. What I like about these is we tend to see different approaches to how we can solve some of these questions. Okay. Go back here, just look at the question here. How many protons? Okay. Protons, neutrons, electrons. Okay. Does Se, I'm just writing it down here and then I'll show you. 79 equal. Okay. All right. So where do you want to start? Okay, with the protons. Perfect. Because we know, what was it? That's not protons. Find selenium on the periodic table. 34. Okay. And so how do I find the number of neutrons again? Very good. Sorry, excuse me. 79 minus 34. You get how many? 45. Thank you. I couldn't read my handwriting in my notebook. Okay. Now, to determine the number of electrons, we said we had 34 protons. Then we have to look at the charge. So 2 minus. So how many electrons do you think we're going to have? Remember, it's a negative charge. So when it's a negative charge, that means there's more electrons. 36. So when it's a negative charged ion, you will have more electrons. And it's the opposite when you have a positive charge, you'll have more protons. Okay? You all right with that? Yes, no, maybe so? Okay. Well, let's continue on here to our next sample. And this is predicting charges for various ions here. Okay. So we are to predict, I like this little pointer, dude. Predict the charge expected for the most stable ion of barium and the most stable ion of oxygen. So I'm going to head on over to the periodic table here. Okay. And who can find, I already forgot which one it was. Barium, right? Where's barium? 56, right here. And does anybody know what family this is called?
The alkaline earth metals.
Very good. Alkaline earth metals. I'm going to speak a little louder since I am farther away from the microphone. Damn, I have to start yelling today. Anyway, okay. So it's in group 2. So if it's in group 2, how many valence electrons, based off of our little trick that we did yesterday, how many valence electrons does it have? 2. Very good. And I'm also going to give you a little hint. Metals will typically, 99.99999%, there's always that unknown. Metals will always form positive ions. So how many electrons does it want to get rid of so it can have the happy number 8? We talked about 8, right? The magic number 8.
Oh. Yes, we did.
I'll like touch base with it, I think.
Yeah.
So again, the whole premise is to everyone have the magic number 8. Have 8 valence electrons in their outermost shell. Well, barium has 2 electrons. And by having those 2 electrons out there in the outermost shell, it kind of makes it unstable. It's not happy. What they say, you'll see this phrase throughout the book, is energetically unfavorable. Okay? It's so close to having a noble gas configuration. You may have heard of that term before. If not, you're going to. Similar to that of a noble gas. So basically, all atoms really are just trying to be just like noble gases in terms of how many electrons they have in their outermost shell. So do you think it'd be better for barium to get rid of 2 or gain 6 electrons? Yes, get rid of 2. Whatever is easiest. So it will get rid of those 2 electrons. So now that we've gotten rid of 2 electrons, what should our charge be for barium? What? If we got rid of 2 electrons, charge. If we got rid of 2 electrons, what do you think our charge on the ion would be? It's going to be really easy for you.
It's 0.
Not 0. We start off with 0. Let's get rid of 2 electrons.
Negative 2. Positive 2.
Positive 2.
It's the
Yes. Yep. When you get rid of, you become positive. It's like when you have, I say this too, when you have friends who are just so negative Nancy's, you're like, I don't want you. Those electrons are kind of like the negative Nancy's. You get rid of those negative Nancy's, you become a little more positive in your life, right? So you get rid of electrons, you become more positive. All right? So yes, barium would have a 2+ charge when it becomes an ion. Let's go the other way. Let's find oxygen. Where's oxygen?
8 times 6.
What's that?
That 6A.
Aha! Yes, group 6.
Yeah.
Number 8. You were right. Your top number is 8, so you're fine. But I'm just excited because now we get to call, like, what is group 6's name? It's a weird one.
Oh, it's the C one.
Uh-huh.
Halogen.
Very close. Yeah, it was in a table.
Oh, I have it. Chalcogen.
Chalcogens. Very good. They were the chalcogens. Okay? Now, as you said, you find it? Okay. As you said, it's in group 6A. So, through our magic brains, how many electrons are going to be in its valence shell? 6. Okay? And how many does it want again? 8. Right? So, we're going to add 2 electrons because it's easier to add 2 than it is to take away 6. Because you'll learn here later on that every time you take an electron away, it actually takes more energy to remove the next one. We don't have to worry about that now. But that's chapter 7. So, we're going to add 6 electrons. No. We're going to add 2 electrons. Sorry, my fault. We're going to add 2 electrons to oxygen, and it's going to make 8 electrons. Still with me? So if we add 2 electrons, what should its charge be? It's only going by the number of electrons. 2 minus. Yes. And adding electrons, because, okay, in a normal normal atom of oxygen, how many protons does it have? 8. And so we're talking neutral, so 8. How many electrons does it have? Neutral? This is my sign for neutral. 8, yes. So in a neutral atom of oxygen, we've got 8 protons, 8 electrons. Charge is 0. Okay? You add 2 electrons. So now you have 8 protons and 10 electrons. Okay? So what's the difference there?
Plus 2. 2 plus.
Negative 2.
Oh my God.
I know, you want to say when you add,
Yeah.
that it's going to be a positive. But remember, what you're adding is actually charge related. Okay? So when you add more negative charges, because again, electrons are negatively charged, when you add more negative charges, you're going to become more negative. Okay? So, oxygen will have a 2 minus charge for its ion. Now let's look at the practice exercise here. We got a couple more here. Okay, so let's look at aluminum. Can anybody find aluminum, or as the Australians say, aluminium? For some reason, they add letters to it. Found it. Where is it? Number 13. Okay, it's right here. So right off the bat, how many protons? How many electrons? Okay. We always think if we start from neutral. All right. What group is it in?
Wait.
3. Group 3. Okay. So, how many valence electrons will aluminum have? Huh? I think you said
3.
3, 3, 3. Yep.
Okay.
That's 3. Remember the group number, the A group number, indicates the number of valence electrons. What kind of element is aluminum? Metal, metalloid, non-metal?
Non-metal.
Metal. Think about soda cans. Metal. Okay, it's a metal. And what did I just be done saying? How metals typically form positive charges. Okay? So, if metals typically form positive charges, aluminum has 3 valence electrons. Again, is aluminum closer to 8 or essentially closer to 0. Closer to 0. Okay? So what do you think aluminum wants to do with its electrons? Those 3 that are in the valence shell. Want to get rid of them, right? And so when you get rid of the negative Nancy electrons, you become
Neutral.
no. You start neutral.
You get more electrons.
You're getting rid of electrons.
I thought, is it negative charge? Positive.
Positive charge. Yeah. When you get rid of electrons, you become positive. When you take in electrons, you become negative. Yeah, it's not about numbers when you talk about positive negative, it's charges.
That's why I said it's neutral, because I thought you'd get rid of the 3, so
Ah.
it'd just be 0.
Nope. Those charges are going to go with the electrons. So, yes.
What happens if the charge is 4, so it's halfway from 8?
I'm glad you brought that up, and we're actually going to talk about that here in a little bit. Very good. I'm glad. See, we're thinking today, folks. Friday mornings, we're thinking. All right. So, yes, back to aluminum. It gets rid of 3 electrons, so its new charge should be positive 3. Very good. Very good. Fluorine.
Can you find it?
9.
What?
Oh, it's 9.
9.
I know that.
9's right here. Okay?
Wait,
No, you wait.
7A.
7A, very good. What family is this?
Oh, God. The halogen.
Halogens. Very good. Okay, we're in the halogens. You're number 9. So, how many protons?
9.
How many electrons?
9.
Very good. Again, we always start off at a neutral template. Okay? And as we saw, or we're told, what is the group number?
7.
7. So how many valence electrons are in fluorine? How
Just kidding.
many? 7. Yeah, it's the group number. It's the group number. What is it?
7.
There we go. All right, so there are 7 valence electrons. Do we want to get rid of all of those 7?
No, we want to add
You want to add 1 to make 8. And what are we adding?
1 negative. 1 negative.
And so we're adding 1 electron, so we're adding 1 negative. So fluorine is going to have what charge for an ion?
Positive. -1.
-1. There we go. All right. You will get this. Okay? You will get this.
I try to think backwards every time I do it.
Yeah, you kind of do have to think backwards. But I want to go back to your question.
Okay.
What if it's something in group 4, which is where carbon, silicon, all that are? They could go either way. They could get rid of 4, or they can gain 4. But neither one is really optimal for them. And that's why we typically see, for a really good example, carbon. Carbon is a part of all living organisms. And we will find out in the not too distant future that carbon, instead of getting rid of or taking in electrons, what it's going to likely do is share. So that's a totally different type of bonding. We call that covalent bonding. What do you think the word covalent means?
2. Like sharing, like because co is like 2.
Like 2, or I like what you're saying before. Co is kind of like sharing. Okay? Okay, co is like sharing. Like co-founder, you both found the company or whatever. Valent, outer shell.
Yeah.
So it likes to share its outer electrons with other atoms and their outer electrons to help, again, make 8. So it's not really getting rid of or taking in. Okay? It's just sharing. Kind of share the burden in order to make everybody happy. Okay? Now, I got this great video. You'll recognize the song.
This is the story of the Alkaline Anions who were trying to get rid of electrons. All of them had 1 in their valence, and they wanted none. This is the story of another family. Group 17 were also known as halogens. 7 electrons were in their valence, and they wanted 8. Till this one day when the metal met the other, the electron transferred to the halogen. Both of them got charged and were attracted. That's the way they became ionic bonds. Ionic bonds. Ionic bonds. That's the way they became ionic bonds. Ionic bonds. Ionic bonds. That's the way they became ionic bonds.
All right. There's a reason why I play that song. We're talking about ions, and what we have yet to discuss is why they are significant. Okay? That's where the ionic bonds come into play. Okay? When we have, think about magnets. Okay? When you have the north part of a magnet and a south part of a magnet come close to each other, what do? They come together. Opposites attract. Right? Have you heard that saying? Opposites attract. Wonderful song by I had to say that, didn't I? Paula Abdul. There we go. You all know who Paula Abdul is, don't you?
Shall we hear the song?
Someday you will. Anyway, she was a judge on what's that singing? The singing show.
The Voice?
No, the
American Idol.
American Idol. Yes. Anyway, like magnets that the opposite attract, when we talk about ions, it's the same case. Opposites attract. Positives attract negatives. Okay? And so that's what we're going to be working with for a while now. Okay? You all got that POGL from yesterday, right? That's kind of what you're going to be working on next week. Okay? What was that look for?
Okay, I was just making sure.
No, it's not due. Like you're not working on it today.
Okay.
It's you're gonna start next week.
I didn't remember you giving it to us, but now I do.
Okay, good. So next week you're gonna do a lot of this work. Okay. Anyway, when we are talking about ionic bonds, we're talking about compounds that have a metal and a non-metal. Metals form what charge again?
Positive.
Positive. So therefore, what do you think non-metals typically charge? Or
Negative.
negative. Very good. So there we have it. We've got positive, negative, metal, non-metal. They're going to come together to form new bonds. Now, prime example, NaCl, sodium chloride, also known as table salt. Okay? Sodium has a what charge? Can you guess? Can you find sodium?
Negative.
It's negative. Wait a minute.
Okay, where is it? Where's it on the table?
11.
Number 11. So, and what side is it on the table? Is it
The left.
left? And left side typically has what type of elements?
Positive.
Metals, which will become positive.
Positive.
So yes, the left side, basically from here over, you have a positive charge. Okay. So sodium's metal. Where's chlorine?
On the right side.
On the right side.
So not positive, it's negative.
Negative. Yes. Excuse me. So we have. So let's look at charges now. What charge do you think sodium's going to have?
Positive.
Positive. Just positive?
Positive charge.
Positive charge? Or I was going to say positive 1.
No.
Positive 1. Okay. What about chlorine?
Negative.
Negative what?
1.
1. Yes. Sodium has a +1. Chlorine has a -1. Now, those charges come into play here in a little bit when we create our formulas. Okay? Those charges will eventually become the subscripts if there are any. You know H2O? Think about this one, H2O. Hydrogen is in group 1. What do you think hydrogen, its charge will be?
Positive.
Well, I just okay.
Now,
Positive one.
here's the thing. I think I know where you're at.
Okay.
Hydrogen is not a metal.
Yeah. That's
It's not a metal, so I knew exactly where you're going with that. And that is true. But it also only has one electron. It's like, I'm going to get rid of that, buddy. Okay? So now let's look at oxygen. Oxygen is negative. Who said it?
2.
Negative 2. Very good. Now think about this. Okay? Hopefully they can see this on, that's going to be upside down. So when we're talking about H2O, okay, we've got hydrogen at +1 charge, right? Oxygen was at -2. Now, here is something cool. Maybe. When we've got ions for metals and nonmetals coming together, their charges have to cancel each other out. So an ionic compound will actually have an overall net charge of 0. You with me still? So if you have oxygen that is 2- and hydrogen that is +1, how do we make that neutral? How many hydrogens are needed to cancel out the -2? So 2 hydrogens, right? If we have 2 hydrogens, each with a +1 charge, 2 times 1 is 2. So +2 and a -2 equal 0. So hopefully you know why H2O is H2O. Because it takes 2 hydrogens and 1 oxygen to have their charges cancel each other out. That's why it is what it is. And now I got to erase this.
it's almost equal to.
Okay. Why am I doing this? All right. We're just getting to my favorite part too. Excuse me. So be paying attention to the classroom this weekend and Monday. Well, I'll probably send out another video, probably where we left off here. So I'm going to make a little note here, slide 50. So I'll probably pick up the video then, and we'll just do that and watch that. I'm going to stop the recording.